I'm Ashley Davis, the developer of DataForge Notebook and author of Data Wrangling with JavaScript. In this quick video, I'm showing you an exciting new feature that's coming in DataForge version 1.5.0. I want to show you the new support that DataForge Notebook has for asynchronous coding. But first, I'll just quickly get set up. I could demonstrate this either using TypeScript or JavaScript, but to keep things simple, I'll just use JavaScript. Now I'm going to preemptively save this notebook in my example notebooks directory. I'm saving it here because I've already pre-prepared some data that I can use from a relative path. So that's just going to make it easier to access the data. Now I'm going to import some preliminary libraries that I need to make sure that I'm set up. I'm importing DataForge and DataForge FS just so I can easily read a data file. You can see that DataForge Notebook is automatically installing the NPM modules that I've imported. What I want to demonstrate first is that DataForge Notebook has always had support for asynchronous coding using the JavaScript await keyword. For example, you can read a CSV data file into your notebook using the await keyword. I'm just going to add another code cell here to display the results of the data that we've loaded. Now this runs so quickly that you can't even see what happened there. But let me explain it. So what we've done here is we've awaited the result of the data file being read, and then we've previewed the data using DataForge Notebook's display function. That displays the data as tabular data, so it's all nicely formatted. This is all well and good if we're using the await keyword, but what if you don't want to use the await keyword? Well, the new feature that I've added to DataForge Notebook for version 1.5.0 is general support for asynchronous coding in JavaScript. I'll create a new notebook to demonstrate. For this example, I'm just going to be using the raw Node.js file system functions. So first, I'm going to import the Node.js FS module. Now I can read my data file, and I'm going to use the FS read file function to do that. This is a callback based function, so I'm going to add my callback here, taking error and data. We're just going to ignore any possible errors. You wouldn't want to do that in production, but it's just okay in this example. And now I'm going to display the data using DataForge Notebook's display function. Now you can see here that I've evaluated the notebook, and DataForge Notebook has waited for that cell and the notebook to complete, and the asynchronous operation. It's waited for the asynchronous operation to complete, and as a part of that, it's displayed the textual data. Now this isn't nicely formatted like it was with DataForge. We could nicely format this if we parsed the CSV data to a JavaScript data structure, but there's no point doing that. And I think I can probably demonstrate this asynchronous support more concisely using the set timeout function. So let's quickly try that. I'm going to do some logging here using the console. I'm just going to be logging some text strings A, B, and C, and I just want to use this to demonstrate how asynchronous coding is working in DataForge Notebook. So I'm going to use the set timeout function here to delay logging of B by 2 seconds. Now let's just run this code and see what happens. You can see that evaluation continues until the asynchronous operation completes, and at that point it's logged B. So it's logged out of order, so it's logged A, C, and then B. And that's because the asynchronous operation happens a bit later, two seconds later to be precise. So I'm just running that again so you can see that it's evaluating for 2 seconds. Now this might even be a bit clearer how this works if I add a second code cell. So I'm just going to reuse the code that I've got. I'm going to copy it to a new cell. Or I just put that cell above. I'm just going to move that down. So I'm copying the code across. I'm just going to update the letters so that we've got a different set of letters that we're going to log here. Now when I evaluate this notebook this time, it's going to be clear that the first cell takes 2 seconds to run. The next cell takes 3 seconds to run. And that's because we made our asynchronous operation in the second cell be 3 seconds long. So you can see that the cells run sequentially, but only after the asynchronous operations for the previous cell is complete. And the whole notebook is kept in the evaluation state until all of its asynchronous operations have completed. It's taken me about 3 months to figure out how to add this full asynchronous support to DataForge Notebook. I've used the Node.js API, the new Node.js API called async hooks. And it's been pretty tricky to figure out, but I've got it working really well now. And this feature even supports nested async operations. Let me show you how that works quickly. I'm going to take that code in the second cell, and I'm going to nest it within the set timeout from the first cell. So you can see I'm invoking a set timeout from within a set timeout, and that's what I mean by a nested asynchronous operation. Now this delays the evaluation of the cell and the notebook out to 5 seconds. So just what you expect. You've triggered an additional nested asynchronous operation, but the notebook's still going to wait for that to complete before it delivers you your final result. So all of this makes it much easier for you to easily use asynchronous code in your notebooks. It's coming at the end of this month with the release of DataForge Notebook version 1.5.0. That's all I wanted to show you today. Thanks for listening. You can find out more about DataForge Notebook by visiting www.dataforgenotebook.com.